I'll guide your gaze slowly, like tracing a beam across a dark room. First, the dim edge of a glow, then the brightest knot, then the faint spill of light that softens everything around it. That is how 3-Eye Atlas appears in still frames to the instruments that can see it now, a small, steady brightness wrapped in a quiet halo, drifting through the star black. As we move our attention along this soft arc, the mind quiets, the eye follows light, the body settles. I keep my voice low, and even because the story moves better when nothing is pushed. We have an interstellar visitor, the third of its kind we've confirmed, discovered by a survey meant to catch more ordinary dangers. A telescope in Chile saw it in the first days of July, and within hours that signal spread across the network where small findings grow into shared sky sense. Many hands measured its motion and found the same answer. It came from beyond our system and will leave again. The bright part of the tale is that it is safe. No crossing with Earth. No errant sweep toward us. Just a passerby noticed in time. Let the light carry you a little farther. A calendar helps. Its closest approach to the sun arrived at the end of October, the point in its curve where warming is strongest and any icy surface awakens. From where we stand on Earth, that moment is hidden by glare, solar conjunction, so our largest ground telescopes must wait. But not every eye is in the same lane of sunlight. Some spacecraft perched at other angles keep looking. An orbiter at Mars can watch from a different sidelight. Instruments designed to study the sun block the bright disk and glimpse what skims near the edge. The picture is incomplete, but it isn't blank. On a long exposure, you'd notice a detail that reassures more than it alarms. A sunward jet, material leaving the dayside as warmth liberates gas, has been photographed, and specialists calmly noted that such jets often point toward the star. When an illuminated side softens and vents, the beam can fan toward the light source itself. It seems counterintuitive, until you remember that the comet is not a mirror ball. It is a textured surface with seams, pockets, and patches that respond unevenly to heat. The quiet halo thickens in those places, then thins again. We stay with the light rather than the noise. Claims swirl, but numbers win the evening. The path is hyperbolic. The closest pass to our star is roughly a little inside Mars's orbit. Planetary geometry keeps Earth well away, at more than 1.5 times our distance from the Sun when the object is most active. These are ordinary coordinates, and they steady the mind. When I read them aloud, the cadence of distances takes on the same even rhythm as a dimmer sliding down. It's enough. If you're curious about why we cannot see it well right now from home, picture sunlight on water, too bright to discern the fish just beneath. Conjunction is much like that. The sun's brilliance saturates detectors, scatters in optics, and frays the atmosphere into wavering threads of blur. Professional teams budget for this curtain. They plan ahead, hand observations to partners off-axis, and set reminders to resume when the glare relaxes. The sky has seasons of clarity and seasons of waiting. We work with it, not against it. The object itself keeps a pace that is both swift and indifferent to our urgency. In the hours near perihelion, the heating can turn gentle simmer into small geysers, and that is why images sometimes show fans, jets, and little wings of brightness. The phrase sunward jet sounds dramatic, but it's just the physics of ice and dust under a hard lamp. If a single region on the dayside opens first, It becomes the bright knot your eye finds. Then the mind imagines shape and purpose. We return to instruments to remind ourselves. A knot is a knot. A plume is a plume. Light makes them seem more deliberate than they are. I find it comforting that multiple observatories across continents and in orbit follow a shared checklist even when the view is imperfect. Record the time, note the geometry, save the raw frames before any sharpening. Compare the tiny shift against predictions. Precision, then patience. It's an old habit in astronomy, a practice that slows the breath because it can't be rushed. The quiet halo returns here as a small leitmotif, seen, measured, and set aside without overwriting what we don't yet know. There is one more pass of the beam before we dim for tonight's first segment. Let your eye go from the bright front to the softer edge, then out into the black, where nothing interrupts the field. Let the numbers you've heard nest gently, dates, distances, safe separations. Like points on a dimmer dial, you can turn down at will. And as we fade, remember that tomorrow's images arrive whether we fret or not, and their light will be weighed the same way, carefully, with unhurried hands and a steady heart, because the universe rewards those who keep their instruments clean and their words modest. Here's the calm tucked inside the numbers. From the console's point of view, the story is a calm soundscape. A relay clicks. The clock ticks. The fan hum settles into a low chord. My notes and yours sit beside this quiet, and together we listen to what the instruments already know. The steady metronome is our leitmotif tonight. A designation arrives first, like a soft chime. 3I, Atlas. The I stands for interstellar, the third such visitor we've confirmed after the first in 2017 and the second in 2019. The name acknowledges the survey that found it, Atlas, the Asteroid Terrestrial Impact Last Alert System, one of those patient networks that keep nightly watch. On July 1st, 2025, a Southern Hemisphere Atlas telescope reported a moving point that didn't behave like our familiar family of comets and asteroids bound to the Sun. Early orbit fits gave the same gentle drumbeat, eccentricity above 1, track consistent with an object that came from beyond and will return to beyond. The board lights stay green. Another tone enters, the secondary label that astronomers use for bookkeeping. C 2025 N1, Atlas. The C signals a long-period cometary nature, non-periodic, not a short-period clockwork, and 2025 N1 fixes its discovery to the second half of the year, first half of July. None of this is dramatic. It's a schema that keeps data aligned and searchable, a filing cabinet that doesn't squeak when opened. The beat continues, unhurried. We add distances to the mix. Closest to the Sun around the end of October 2025 at about 1.4 astronomical units. Inside the orbit of Mars, but far outside the danger stories that busy headlines will sometimes amplify. Closest to Earth later on, still wide and calm, roughly 1.8 astronomical units away, a spacing that belongs to the safe middle registers of the score. If you prefer miles, think on the order of 160 to 170 million at its nearest to us during this passage. Each number is a soft percussion, laying out a tempo you can trust. Safety is not a feeling here, it's geometry. The plane of its path inclines slightly, relative to our planet's thin disk. The object passes near Mars first, far from Earth's lane. It is hyperbolic, on an open path that does not loop back. The music of the orbit is legible to anyone willing to count the measures. You start with position and velocity, propagate forward under gravity, include small vents from warming ices if needed, and find that the line never crosses ours. It's reassuring, and it should be. We can also listen for who is watching. Ground observatories took early spectra and images before the sun's glare grew loud in the instruments. A large telescope in Chile recorded a compact coma and a short tail. Spacecraft shifted into the ensemble. Mars orbiting platforms used their different vantage to catch the traveler when Earth-based eyes were dazzled, and solar coronagraphs gathered time series near the bright edge. Each platform contributes a phrase: ultraviolet here, optical there, sometimes infrared, and the composite shapes into a calm, polyphonic truth. A comet-like body, active as it warms, moving along a track we calculated weeks and months ago. The interstellar part matters for context, not for alarm. Most comets you hear about were born in the deep freeze of our own distant cloud and return on long ellipses. This one was formed in someone else's cold and happens to cross our stage once. That is why the 3i feels like a bell you don't hear often. We have very few confirmed notes in this register, so everyone tells us a little more about how other systems cook their ices and dust. When sunlight strikes those outer system materials, they release gases that glow in familiar lines: hydroxyl tracing water loss, cyanide from carbon-nitrogen chemistry, sometimes sodium or nickel as grains warm. The specific mix is a melody we can compare to comets born at home. At this point, the console sounds settle into a softer hush, and we can place one long line across what we know. Because the naming convention encodes both origin and discovery timing, and because the distances to Sun and Earth can be computed with high precision from weeks of astrometric measurements. The identity of this object, an interstellar comet discovered by Atlas in early July 2025, safely clearing our orbit while passing about 1.4 AU from the Sun and roughly 1.8 AU from Earth, rests on systems that have been tuned, tested, and cross-checked across observatories, spacecraft, and time. You may wonder whether interstellar implies anything exotic about its shape or intent. The quiet answer is that interstellar here is a travel history, not a function. The instruments do not read purpose, only position, brightness, and spectrum. They tell us it is active under heat, like a comet should be, that it brightened on approach as expected, that its course fits a hyperbolic solution. If you take comfort in consistency, this is good news. There is an elegance to the way these systems talk to one another. A survey telescope flags a mover. A minor planet center collates reports and refines the orbit. Large telescopes gather photons heavy with chemical hints. Solar watching spacecraft lend coverage when the sun gets noisy. Radios and networks stitch timing together so that everyone is counting the same seconds. Each handoff is another quiet tick in the room. Each confirmation lowers the noise in our minds. I like staying with the sound of it. The slow fans, the soft relay, the metronome that keeps all this work on beat. When numbers disagree, the rhythm stutters. When they agree, you feel the synchronization in your shoulders. Here they agree more than they do not. And where they do not, the differences are small and technical. The kind you resolve with another night on sky or another pass of calibration. This is the comfort of well-kept instruments and well-worn methods. So for what it actually is, we keep it simple. It is a comet from another star system, designated 3i Atlas and also known as C2025 N1 Atlas. It was discovered on July 1st, 2025, by a vigilant survey. It reaches its closest pass to the Sun around the end of October, well outside Earth's track. Its closest approach to us is still comfortably distant. It behaves like a warming comet, and is being watched from multiple vantage points with care. That's the whole chord. We can hold it quietly and let the extra noise fade. The same soft rhythm carries us forward. A small question first, asked softly, so it doesn't wake the brain too much. Why does the Sun seem to hide our visitor right now? The gentle answer is that the object slips close, not in miles, but in angle, and the Sun's brightness lays a broad curtain across our line of sight. The deep glare is not angry, it's simply overwhelming. Cameras and mirrors bloom, air shimmers, angular separation shrinks until the faint thing is sewn into the fabric of daylight. Astronomers call this solar conjunction. From Earth's viewpoint, the Sun sits between us and the comet for a while, and even the finest optics struggle when a billion-watt lamp occupies the same patch of sky. The fix is not force, but clever staging. Some observatories place an artificial disk, an occulting mask, inside a special telescope, so the solar face is blocked and the surroundings come up out of the wash. Those instruments are coronagraphs. They specialize in seeing what lives in the glare's hem. Other times, a change of seat helps. A spacecraft around Mars, or a probe inward or outward of Earth, watches from a different row and catches what we miss. This is exactly the geometry now. Near the end of October, the path of 3i Atlas bends through its sunside turn. From Earth, that moment happens behind the curtain. From elsewhere, the folds open. When ESA's orbiters at Mars looked during the first week of October, they weren't fighting our daylight, so their cameras and spectrometers added clean stitches of data to the quilt we're building. Solar watching spacecraft, SOHO and Stereo among them, point coronagraphs at the bright disk, slide the mask across the face, and watch the near-sun field for anything that strays into view. It isn't glamorous, it's patient. If you like tangible reasons, think of the simple angles. Observers speak of elongation, the distance in sky degrees between a target and the Sun. Above a certain threshold, a comet is easy in twilight. Drop beneath it and the atmosphere turns the light into wool. The optics gain ghosts, and the detector starts to saturate on every scattered ray. At perihelion, 3i Atlas sits at a small elongation, so we wait a beat. Then the cloth shifts. The sky opens again. There's comfort in how ordinary this is. Every mission planner carries a conjunction calendar. When Mars slips behind the Sun from Earth's line, we pause commands for days. When a comet passes near the glare, we hand the watch to instruments built for that edge of brightness theatre. Our interstellar traveller doesn't know or care about any of this. It simply follows its path, while our coverage passes from one vantage to the next like a relay baton. Now, a minute without facts, just the texture of it, so your thoughts can lower their shoulders. The Sun murmurs in radio hiss you cannot hear. Heat climbs the observatory walls at noon, and then slides away, leaving the dome cool to the hand. A camera head ticks as it settles into its thermal set point. Beyond the blue, the solar wind combs past and past, unending, a steady press on dust so fine it never knows it's being moved. Somewhere a spacecraft wheel makes a careful correction, so calm the sensors barely notice. Inside a control room, the last plots of the day sit pinned on dark screens, a few pale points, a slanting line, a margin left empty on purpose. The curtain glows, the curtain dims, breathing goes on. When Earth regains its view, the same telescopes that stepped back return to work. They do not expect fireworks, they expect continuity. Position and velocity will be measured against predictions, spectra against earlier baselines. If the coma thickened, they will quantify it. If a tail lengthened, they will trace it. If the nucleus brightened or softened, they will fold that into models and move on. A conjunction window doesn't create mystery by itself. It only withholds the middle of a story we can still read at the beginning and the end. Even the special instruments that dwell near the sun's edge live with limits. Coronagraphs block the face to reveal the surroundings, but the closer you look to the inner rim, the brighter the scattered light becomes, and the more careful you must be with interpretation. What you see is real, yet it must be coaxed from a field where the background is loud and the features are faint, so the calibration files matter as much as the photons themselves. This is why professionals speak quietly in this season and prefer raw frames to sharpened snippets. The curtain is beautiful, and it can be tricky. All of this keeps the tone mild when we speak of timing. Some will note the convenience of a hidden moment and imagine more than the geometry gives. Our work, especially at night when minds like to wander, is to set the scene correctly. The sun's light makes a curtain, yes, but it is the same curtain that passes across Mars missions every cycle and across comets every year. And in a few days the hem lifts, and we simply check where the traveller is, what colour the glow has become, and whether the numbers still hum in tune. In a long view, it's wonderful that other eyes, at Mars, along heliophysics orbits, at solar sentinels, keep watch while we rest, and that their vantage patches the gap because a tapestry reads best when it is fully woven, and this is the part where many hands keep the weave even. Let your shoulders drop into that knowledge. The quiet curtain is real, but it is thin, and it moves, and it does not change the path under it. Soon, Earth's lane will clear, and familiar domes will swing back to the coordinates we marked before the glare rose. For now, the best thing is the simplest. Breathe, trust the angles, and know that this is how sky work goes when the sun draws its soft drape across the stage. We return to the quiet traveller. Postcard in time, late October, an afternoon edge where the feeds feel busy while the sky is bright. A short, grainy clip appears, then reappears, passed hand to hand like a note slid down a quiet aisle. It claims to show 3-eye atlas up close and engineered, with neat points of light and hard lines that pull the eye. The message travels faster than the measurements. Minds sprint, hearts follow. We slow to a walking pace. Journey works best with signposts. First signpost, origin. Real astronomical data has a trail, observatory, instrument, filters, coordinates, timestamps. It lives as raw frames with headers that list everything from exposure time to detector temperature. Those files let others retrace the route, match the star field, and confirm that the view is what the camera truly saw. A compressed video without that trail is a story without mile markers. It might be true, but it is not yet a route the rest of us can follow. Second signpost, comparison. Genuine frames of this object from large observatories show a small nucleus, wrapped in a diffuse coma, and, at times, a subtle tail. Space agencies and major telescopes report the same tune, active under heat, consistent with a comet, safely distant from Earth. You can set the viral image beside those reports and ask the simplest travel question. Do these paths point to the same place? When the shapes disagree, the map favors the set with better coordinates and the cleaner logbook. We take the third signpost from craft rather than craft claims. Instrument people check for stars in the field, then test whether those stars form the expected pattern for the time and pointing. They fit the point spread function, the way a sharp point of light becomes a small blur in a specific camera, and see if the alleged lights have the same shape as nearby stars. They look for the signature of saturation bloom, where an overfull pixel spills charge into neighbors and draws artificial ridges and beads. They compare the noise in the dark corners to the noise around the object to spot over-sharpening artifacts. These are the steps, and they are as steady as placing one foot in front of the other. Some will ask about the watermark in the corner of the clip, as though a stamped code could stand in for a passport. Watermarks tell us who wants credit, not who held the telescope. They add nothing to provenance, and they can be added to anything by anyone. The way forward still runs through headers, calibration frames, coordinates, and independent repeatability. Let's keep walking. Claims that a shape looks engineered sometimes arise from image processing itself. Deconvolution can ring a bright nucleus with evenly spaced ripples that resemble nodes. Aggressive denoising smooths gradients into plastic sheen. High contrast pulls weak jets into hard lines. A long exposure integrates a sequence of small flares from a rotating coma into a tidy row of points. None of this requires intention. It only requires software pushed a little too far. When a road grows strange underfoot, you check the sign again, rather than inventing a new town. There is also the simple physics of forward scattering. Small dust grains can send sunlight strongly in the direction they were already traveling. So at specific viewing angles, the sunward side of a coma can brighten into a clean, compact gleam. If you isolate a narrow color band that lights up one molecule, cyanide for example, the dusty continuum fades and the gas glow tightens. The result reads structured to an untrained eye, but a careful comparison across filters usually turns that structure back into ordinary comet light. What about timing? It feels tempting to treat the clip's appearance during conjunction as a grand reveal by design, like a bend in the road that hides a destination until the last step. Conjunction is not theatre, it's geometry. The sun sits near the target in our sky, so the dynamic range becomes brutal and ground-based images degrade. Other vantage points, Mars orbit, heliophysics sentinels, carry the baton while we pause. When the glare eases, we pick up the track and see whether our traveller stayed on course. That is the test that matters, and it happens after the noise settles. A deliberate pace helps here. If the clip shows a real object with deliberate lights along a rigid spine, other instruments will see hints of the same when the angles improve. If it's an artifact, the phantom structure will not survive independent cameras, different filters, and changed geometry. The path forks. We follow the branch the data chooses. Meanwhile, we avoid building a destination out of a single blurry mile. It is also worth remembering how ordinary strangeness can be in comet images. Jets can repeat because a rotating nucleus exposes the same sunlit vents each cycle. Anti-tails can appear to point toward the sun because of perspective and dust grain size sorting. Nickel can glow without iron if chemistry favors volatile compounds that release one metal more readily than the other. None of that asks for engines. Each of those steps already sits on the map we use every season. We keep the tone mild because the most powerful filter we own is skepticism used kindly. Extraordinary claims need the longer road, raw data, independent confirmation, spectra that show lines beyond familiar physics, astrometry that refuses to fit gravity plus outgassing. Without those, the destination stays on the horizon, no matter how many times a clip is reposted, and no matter how neat the lights look after someone drags the sharpness slider. There's a quiet comfort in that discipline. It lets us rest while the numbers travel on our behalf. In the second half of any long walk, you feel the rhythm, and that is where we are now, with a calm expectation that the post-conjunction track will either match the predicted path or not. Because a real maneuver would tilt the route in ways that even modest telescopes can measure once the sun slides aside, and if it does not tilt, we lay this clip down, with the many that brought excitement before the evidence arrived and left quietly after it didn't. The soft margin returns as our small leitmotif, a gentle edge between what we'd like to have seen and what the instruments will actually show. For tonight, we place the postcard carefully back in the stack and mark the next waypoint. On the map, the dates when larger telescopes regain the sky and the geometry improves. Then we breathe, step off the trail, and let the path wait for our return. Let's drift to the next clue. Close up. A single pale pixel swims on a laptop screen in a quiet room, the kind of speck you'd miss if you blinked. The cursor hovers, then the exposure scale lifts, and that speck firms into a point with a faint wedge ahead of it, as if a small craft were easing past a harbour light. The bright leading edge is our leitmotif, tiny but insistent. The camera's timestamp says late October. The coordinates match the day's ephemeris, and a backyard telescope has done what backyards often do in astronomy. Thread a needle the big domes can't, simply because it is pointed where the moment allows. Widen. The setup is modest. A solar-ready filter on a small scope, a cooled camera, software most amateurs know by heart. The trick is not power, but geometry. When the object sits near the sun in angle, the usual night gear is useless. A solar rig can look closer to the glare without frying a sensor. The frame that results is rough and honest. Coloured speckle lays across the pixels. Hot columns blink. The target is a compact, bright front with a soft, conical wake. Not a long, painterly tail, not a dramatic fan, just a concentrated forward gleam and a short spill behind. You can almost hear the quiet of the capture. No fanfare, no overlays, just a still that asks to be read gently. The value of a single frame from an amateur isn't that it settles an argument. It's that it pins the traveller on the chart when other ships can't see the buoy. The posted time matches the predicted position from the public ephemerides. The sky location lines up. The angle to the sun explains the compactness. Others in the community do the sailor's work of triangulation. They rotate the frame to match north-up convention. They compare the shape to a professional image taken weeks earlier in a different filter. They look for field stars to anchor scale. These habits keep the course true. This bright front is not automatically a beacon. The simplest reading is sunlight meeting dust at a favourable angle. Forward scattering can lift the sunward side of a coma into a tidy flare. When grains are small, and the phase angle is right, and narrowband filters can collapse a diffuse glow into a crisp knot if a single molecule dominates the light. The short wake is consistent with low dust output or larger grains that don't drift quickly. None of that asks for engines. It asks for patience and a second, independent look. Even so, the amateur frame gives us a waypoint worth noting. It affirms that something compact and asymmetric sits at the predicted coordinates. It shows that the leading edge is unusually bright for a moment in this geometry. And it reminds us how noisy real raw data can be, because the very texture of the pixels, the salt and pepper noise, the faint banding, from the camera readout, the scattered glints from the solar filter, cautions against drawing hard lines where the signal is only a little taller than the sea state. If this were a sea voyage, this would be the small lantern glimpsed between swells, not the lighthouse that defines the coastline. It tells you the inlet is where the chart said it would be. It says, proceed, but do not hug the shoals. And in that spirit, observers with larger apertures and different filters will try for the same geometry once the sun's curtain slides by, because a real structure tied to the nucleus should either rotate with the body or persist in a way that survives new angles, new optics, and new hands. Artifacts tend to wash away when the tide turns. Features tied to physics tend to return. There is also the social sea to cross, the way a single image, especially when posted during a high glare week, can be swept into currents of commentary far from its technical context. The steady course is to pull it back to basics: time, place, instrument, processing, field stars. A raw post with coordinates is better than a polished clip without provenance. A frame that invites re-reduction by others is more useful than a sharpened collage that cannot be retraced. The amateur did the helpful thing here. He posted the when and the where, and he showed the raw look, blemishes and all. Across that wider field, professional images from August and early October have already shown a sunward jet in narrower filters, along with a condensed coma and a short tail in broadband. The amateur's bright leading edge rhymes with those reports without being the same picture, which is what you want when you keep a logbook. Echoes, not clones. When Earth's view returns, the rhythms that matter will be rotation-linked changes in the bright knot, color differences between filters, and the way the short wake grows or fades night by night. If the bright front is a stable landmark, it will anchor. If it is an angle trick, it will soften into the surrounding glow. The comforting truth is that a single frame can be both meaningful and insufficient, like a buoy that marks a channel but doesn't tell you the depth everywhere. And because this is a long, careful crossing, we let the next tide bring new readings. In the meantime, the amateur's lantern holds its place on the chart, a neat note in the margin that says, "Seen here, this bright leading edge," while the larger ships of the fleet turn their glass back to the horizon and resume the slow work of mapping the whole bay. The same soft rhythm carries us forward. If sunlight reaches a frozen surface, then a thin breath rises. If a breath rises into space, then it diffuses into a cloud. If the cloud grows bright, then we call it by its old name, coma. The rule is simple, and it helps our minds settle. A comet is a small nucleus, ice, dust, and rocky grains, that warms and vents. The glow is not the body. The glow is the mist around it. Most nights this mist behaves. Dust lifted from the surface drifts away from the sun under radiation pressure and becomes a dust tail, broad and pale. Ionized gases, guided by the solar wind, stretch into a narrower, straighter ion tail. These two can coexist like twin veils, one faint and fan-like, one taut and blue-toned. When you see textbook sketches with a fuzzy head and two trailing strands, that's the orchestra playing its standard melody, and it remains a useful score. If the nucleus rotates with active patches, then jets appear as localized plumes within the mist. As the body spins, each vent turns in and out of sunlight, so the jets can seem to pulse or repeat, regularity born from rotation, not intention. If the viewing geometry favors it, then a jet on the day side can brighten the face toward the sun. Forward scattering does the rest. Small grains thrown off the warm side reflect light in a direction that feels forward to them, so the lit face can look compact and intense, the way fog thickens in a headlamp. Sometimes a third feature plays tricks. An anti-tail, the appearance of a sunward extension, emerges when larger, heavier grains released earlier form a thin sheet in the comet's orbital plane. When our line of sight slips nearly into that plane, the sheet foreshortens and seems to point toward the sun. It feels reversed because our eyes expect tails to flee the star. Perspective and grain size quietly disagree. Nothing exotic is required, only timing and angle. Pause a moment for the image-only weave. Mist folds over darker mist. The bright face has the softness of breath on glass. Far beyond the glow, space holds steady and uncolored, the way a cold morning waits before the first footstep. You can almost sense the faint drift of particles, a snow that never lands, each grain so small that it has forgotten the weight of falling. Somewhere in the quiet, the sun hums like a far machine, while the mist thins and thickens, according to no clock but warmth. Let the edges blur until only the gentle bright remains. Back to the plain workings. If a filter is chosen to isolate a specific molecule, then the picture can tighten in surprising ways. Narrowband filters that highlight cyanide or hydroxyl suppress the dust continuum. The coma shrinks from a woolly cloud into a compact core, because you are now seeing only one glowing species. If you switch filters or observe in broad color, the same region loosens again into haze. This is why single filter images can look engineered to an untrained eye. The neatness comes from the bandpass, not from machinery in the sky. If the tail seems short, then dust production may be low, grain sizes may be larger, or the viewing angle may hide the spread. At small phase angles, sun nearly behind us, the whole coma can brighten uniformly. At large phase angles, sun nearly beside the line of sight, the forward scattered face can dominate and make the opposite side look trimmed. These are the same optical games that make a cloud bank blaze at sunset and fade at noon, only played on a stage so vast that distances lose their urgency. Even the absence of a classic tail near the sun does not demand engines. If a nucleus is venting mostly gas with few motes, then the measurable glow lives close in, and the dust tail waits to grow farther out. If grains are big, radiation pressure nudges them less, and any tail stays stubby. And if the solar wind direction bends the ion tail away from our line, we might miss the narrow strand altogether until geometry shifts. A comet is a maker of mists, and the mists answer to light, to charge, and to the breeze of particles streaming from the sun. There is comfort in the way these if-then statements land. They do not forbid surprise, they simply tuck it into rules we already use. And when someone posts a shape that looks like lamps along a rigid spine, we can hold it up to this mist logic and ask whether filters, scattering, processing, or perspective could have drawn stage lights on fog. Because fog loves to imitate structure when you push contrast hard enough, and because the eye, eager for intention, is easily persuaded by sharp edges carved from soft things. One long truth, slow and even. The forces at play. Sunlight warming ice, vapor dragging dust, photons pushing particles, magnetic fields guiding ions. Compose a patient physics that can mimic geometry when seen from certain angles or through certain colors. So the safest habit is to compare many looks at many times and let the recurrent features be the ones you trust, while the one-off lines fade as the weather of image making. If all of this sounds humble, that's because humility is a good blanket for interpreting mist. We will see jets come and go, faces brighten, wakes shorten, tales return. And if anything remains that won't sit inside these rules, if it repeats under changed angles, if it survives filter swaps, if it rotates with no regard for spin or sunlight, then we will name it plainly and follow it carefully. Until then, the older language is enough. Nucleus, coma, tail, jet, phase angle, scattering, solar wind. The map we already carry still fits the terrain. Here's the calm tucked inside the numbers. 3 handrails to hold while we drift through chemistry. First, a spectrum where carbon dioxide glows strongly. Second, a faint fingerprint of water traced by hydroxyl. Third, a set of narrow lines from nickel that rise without a matching forest from iron. Each is small, but together they steady the mind. The leitmotif tonight is a pale CO2 breath, easy to picture, easy to release. Start with the carbon dioxide. When JWST turned its infrared eyes toward the traveller in August, the signal gathered into bands that speak plainly. This coma is CO2-rich, unusually so compared with many comets raised in our own deep cold. That does not make it exotic by itself. It makes it informative. High CO2 relative to water can mean the surface layers are shaded from heat in a way that keeps H2O quiet, while CO2, which sublimates more readily, leads the dance. It can also mean the nucleus formed, where CO2 ice was common, nearer to that chemical's frost line in its birth disk. Either path stays inside ordinary physics, and both help us understand the neighborhoods where other stars build small worlds. Now the whisper of water. Swift's ultraviolet camera, small, nimble, and often overlooked, caught a soft band near 3085 angstroms, the telltale emission of hydroxyl, a product of sunlight breaking water molecules. Detecting OH beyond 3 astronomical units is not everyday work. It means either the nucleus or the coma carries water out, where the sunlight is still gentle. One possibility is that large icy grains, released earlier, are drifting and slowly giving up vapor, making the water's signature in the space around the nucleus rather than only at its skin. That quiet reading fits the mood. No fireworks, just a slow exhale. The nickel lines enter differently. Visual spectrographs on very large telescopes reported slender knee-eye features, while iron lines kept their distance or fell below the noise. Nickel in comet comae is not unprecedented. Sunlight can tease atoms from metal-bearing dust under the right conditions, and in more than one comet, we've seen both Ni and Fe. Here, the emphasis on nickel raises eyebrows without demanding conclusions. A chemist's explanation sits nearby. In a CO-rich environment, nickel can form a volatile carbonyl that frees atoms at comparatively low temperatures, while iron does not play that game as readily. Photons then break the molecule and leave nickel shining where we can measure it. Nothing about that requires technology. It requires carbon monoxide, metal-bearing grains, and time in the light. Across these instruments, the palette is simple. Infrared for CO2, ultraviolet for OH, optical for CN and metals. Cyanide is present too, a routine comet companion born of carbon-nitrogen chemistry that brightens as the coma warms. If narrow filters isolate CN, the comet's face looks tighter, almost engineered, because you've removed the broad dust glow and kept only a single species. Swap filters, and the neatness loosens back into a familiar haze. That is the kind of context that protects sleep. When a picture looks strange, try a different color before you change your story. In the second half of the night, as data cool on disks and screens dim, a gentler coherence emerges. A CO2 forward coma can keep water faint until later. O can appear even when the nucleus isn't roaring, because grains carry their own reservoirs. Nickel can glow without iron if chemistry gives it an easier path into the gas. And CN can rise as sunlight deepens its reach. So a spectrum that seemed unusual at first becomes a sequence that breathes in time with distance and heat. A low drama progression where each step follows the last with the same slow inevitability. As dawn coming to a shuttered room while instruments finish their runs. It helps to remember scale. A narrow line on a plot is the light of untold atoms drifting across tens of thousands of kilometers, all of them moving with a patience the human body rarely matches. That's why we speak softly here. The truth is a sum over many photons, many nights, many apertures, and it resists any fast verdict. When reports claimed nickel without iron, the way forward wasn't to shout. It was to cross-check slit widths, look up calibration lamps, compare to other comets, and ask whether the carbonyl pathway had the right ingredients in this coma. Because in a universe that loves repetition, the simplest mechanism that fits the numbers is usually the right place to rest. A long line to tuck you in. Even if interstellar travel adds a certain glamour to the name, the glow we measure is still light scattered, absorbed and re-emitted by the usual suspects: CO2, water products, simple radicals, and a few stubborn metals. And the way those signals rise, falter, and rise again as the sun warms the surface will tell us more about the birthplace of this small wanderer than any single dramatic frame shared in haste, because chemistry is a diary, written slowly, and read best when the room is quiet and the pages are turned with unhurried hands. We return to the quiet traveller, a soft colour to guide us, sodium yellow, like the quiet rim of the sun seen through a safe filter. Let that pale line be our guide across the sky tonight, tracing the ecliptic, the broad, golden roadway where most planets roll. When an interstellar traveller seems to follow that line, the eye leaps to purpose. The numbers counsel patience. Picture the ecliptic as a luminous stripe running from horizon to horizon. Our surveys, Atlas among them, spend much of their time near this stripe, because it is where asteroids and comets born here prefer to wander, and where the opposition geometry is kind to faint objects, telescopes sweeping along that glow harvest, movers efficiently. A visitor from far away that happens to cross that zone becomes far easier to see. Selection is not intent. It is simply where our nets are strongest. 3i Atlas arrives from a direction not far from that golden lane. Early orbit fits put the inclination only modestly tilted from the planetary plane, and that geometry sets up a simple choreography. The object's path slices through the region where Venus, Earth, and Mars trace their orbits, and later its outbound leg eases toward Jupiter's domain before the hyperbola opens to interstellar black again. Near here means sky near, angles, and projection, while real distances remain wide and calm. Tens of millions of kilometers still count as close in planetary dynamics. To human eyes, those spacings are oceanic. Because the path lies near the ecliptic, planetary flybys of a sort appear in tables and articles. They are not meetings so much as polite passings in a brightly lit hallway, measured, predictable, and far outside the sphere where tides and talks do anything dramatic. The advantage for science is coverage. Worlds with orbiters, Mars especially, can watch from off-Earth vantage points as the traveller cuts across familiar longitudes. Each look adds another sodium yellow tick to our quiet ruler. Why would an interstellar object arrive near the ecliptic at all? Chance suffices. Space is large, but gravity funnels. The sun's well gathers paths from many directions, and the set of trajectories that produce bright comets in inner system skies is biased toward those that graze the planetary plane, because that is where the illumination climb is steepest, and where our watchers are waiting. Add to that the practical truth that survey pipelines flag things near the ecliptic more efficiently than things far from it, and an apparent preference emerges that belongs to our methods as much as to the sky. There is a second, subtler bias. To mark an object as interstellar, you need a good string of astrometric dots while it is still far out, before non-gravitational pushes complicate fits. Those dots accumulate best when the object passes through fields our surveys already tile nightly, the ecliptic belts, where cadence is high and weather gaps are small. In that sense, the sodium yellow line is also a metronome. The exposure schedule taps along it in time, and travellers crossing it are more likely to be recorded steadily enough to reveal that slight superunity eccentricity that labels them unbound. Some commentators list the sequence, near Venus here, near Mars there, deeper toward Jupiter later, and here a mission plan. The karma reading is geometry doing what geometry does. With so many worlds sharing a single luminous lane, any path that lies almost in that plane will seem to nod at several planets as it passes, the way a long contrail can line up with city lights on an evening drive, even though neither knows the other exists. If there is no measurable exchange of momentum, no sharp, calculated change in the track, then the nod is just that, a line of sight and a little romance in the wording. Numbers can soothe that romance. Tables of minimum distances, relative speeds, and encounter timings show separations too large for significant gravitational sculpting beyond the sun's dominant hand. Add in the object's high heliocentric velocity, and you get brief, gentle passages with negligible deflection. It's the celestial equivalent of crossing the same wide boulevard as a few buses that never slow down. They look aligned for a moment, and then everyone continues elsewhere. If a true intentional tour were underway, we would expect tighter, energy-efficient passes tuned to extract or donate speed, and we would later see residuals in the orbit that insist on forces beyond ice and sunlight. Even our intuition about aligned with the ecliptic needs rehearsing. Random arrivals are three-dimensional, yes, but our ability to declare a mover interstellar is not uniform across that volume, and the data we cherish are gathered in the sky strips we scan most. The ensemble of discovered interstellar visitors is therefore a product of the sky we actually watch, not the abstract sky of possibilities, sodium yellow where we look, silent black where we do not. Here is a longer breath to rest inside. When a small, unbound body cuts the planetary roadway at a shallow tilt, the effect is to place it under bright, frequent scrutiny from many instruments positioned along that line, and this saturation of attention can make the path feel curated, even though it is only well observed, because instruments live where logistics are easiest, near the ecliptic, near opposition, near the golden angles. And the mind, eager for authorship in every pattern, forgets that a map of our habits is not a map of another traveller's aims. If there is design to be found, it will not hide in the gentle poetry of near the ecliptic or brushed past Mars. It'll live in the post-conjunction astrometry, in residuals that line up like careful ticks against gravity-only curves, or in spectral lines and thermal glints that refuse to be folded into dust, gas, and sunshine. Until then, the sodium yellow guide does its simple job. It marks the plane of our neighborhood, it organizes our watch, and it explains why this visitor appears to travel the well-lit road. Here's the calm, tucked inside the numbers. We'll take a slow walk together, one careful step at a time along a path that curves near the sun. The track is already drawn. Our traveller moves fast at the low point of that curve, and that speed changes what any push can do. If a nudge happens where motion is swiftest, the whole journey after bends more than it would have otherwise. This is the Oberth window, and it's just good housekeeping in orbital mechanics. Imagine our steps on a gentle downhill. Each stride buys more ground because gravity has already given us pace. A rocket burn at that lowest place, perihelion, for an object around the sun, adds energy most efficiently. The math hides in plain words. Kinetic energy goes as speed squared, so a small increase in speed, where speed is already high, yields a larger gain in energy than the same increase would at the top of the hill. If you burn there, you get more travel for the same fuel. If you burn against your motion there, you shed speed most effectively and can settle into a bound orbit that would otherwise be out of reach. Our visitor's closest pass sits at the end of October, behind a bright curtain from Earth's perspective. That is simply geometry. The tests that matter arrive right after the glare fades. We measure position on the sky with ordinary telescopes, night after night, and compare those. Points to the path predicted by gravity plus the gentle, lumpy thrust supplied by outgassing. Comets push themselves a little as their vents exhale. The direction of that push tends to follow the sunlight and the shape of the active areas. If the residuals, the differences between the measured track and the predicted one, are small and random, the traveller kept to natural forces. If they point one way with a size too large for comet breath, we take another step and look harder. There's nothing mystical about how the check is done. Observers collect times and angles, software fits an orbit, analysts inspect the leftover wiggles. A sustained dV near perihelion would tilt the outbound asymptote of the hyperbola, change the period of any temporary sun-skimming loop, or shift the timing of appearances at plotted checkpoints. Even modest telescopes can notice if the deviation persists over nights, because the sky is a reliable ledger. Once a path is written in it, changes show as clear arithmetic rather than impressions. Pause with me for a minute of quiet scenes, no new facts, just the sound of the walk. Footfalls soften on warm concrete outside a dome, the slit hums and stops, the night air carries a dry metallic coolness after sunset. A laptop fan brushes the ear like distant surf. A guidance star settles into a crisp dot, then blurs, then tightens as the tracking loop finds its breath. A mechanical clock on a wall ticks with a stubborn kindness, the older tempo holding its ground against the fast digital display. In the dark, a red spill from a keyboard pools like a tiny harbour where hands rest, then lift again. Somewhere, far beyond the hill of this building, a spacecraft turns a wheel by a fraction of a degree, the motion so small that only the numbers know. Back on the road. A real Oberth-style manoeuvre would likely announce itself in two ways. First, in that post-conjunction astrometry, then in the energy bookkeeping. If the object leaves the encounter with more heliocentric speed along a clean line, the Sun will let go sooner. If it leaves with less, it may loiter, trade the open hyperbola for a long ellipse, or choose an orbit that keeps it within the inner system. Either path writes a signature into the data. Natural outgassing can mimic a push, but it usually wanders with rotation, season, and surface patchiness. Deliberate thrust would tend to keep a direction for longer, especially if timed to the very bottom of the well, and the magnitude would likely exceed what a few vents can manage in a short span. We also glance for auxiliary hints that sit beside the walk but do not replace it. Spectra might brighten in lines that suggest heated exhaust or unusual molecules. Infrared instruments could see a thermal bump that lingers longer than solar heating. Alone explains. Light curves might steady if attitude control damped a tumbling spin. These are side paths, not the main road. The main road is still position versus time, because celestial mechanics has a way of turning speculation to dust when the numbers refuse to follow. If the window passes with no telltale shift, that is its own kind of answer. The object will fade into the outbound leg, its speed and angle matching Pragman's to within the more certainties of air, mirrors, and clocks. The slight added drift from vents can be modelled, and the rest of the story is a long, cold coast back to the dark between stars. Should there be a shift, we will not need drama to say so, only calm language and the usual charts, because a meaningful DV will repeat night after night in the residuals, until we fit a new orbit that admits an extra push. Here is the long sentence worth keeping in your pocket as you settle. The Oberth window is not a riddle or a rumour, but a place along a curve where speed multiplies the value of any push, and because the date and distance of that place are predicted, any after-the-fact change in the outbound path is testable, with ordinary astrometry done by ordinary telescopes working from ordinary nights, which is precisely why this chapter can end softly, with our steps slowing and our attention ready for the next measured waypoint, rather than the next loud claim. The same soft rhythm carries us forward. Dear listener, lean back and let me set a small lamp on the table between us. The light is soft, and everything we talk about will be held up to it. No theatrics, only what would truly shine if it were there. Evidence in this quiet room begins with position in the sky. Astrometry is our oldest lamp. Night after night, telescopes record the exact spot where the traveller appears, against a fixed web of stars whose coordinates we trust. A model, gravity, plus a gentle nudge from outgassing, predicts tomorrow's spot. If the object is only a comet, the differences between prediction and measurement wander a little, change with rotation, and fade as geometry changes. If something else is pushing, something planned, the differences line up and keep pointing, night after night, in the same direction with a size that outgassing can't comfortably explain. That coherence is what matters. Not one bright dot, but a procession of them refusing to fit the curve unless we add a deliberate dV near perihelion. Now we lift the lamp and look at colour. Spectroscopy spreads the comet's glow into a band of hues laced with thin lines from molecules and atoms. Comets share a common palette: CN and OH, CO2 and dust features, sometimes sodium, sometimes metals teased from warm grains. A different story would need different lines, narrow, stable features that don't belong to known comet chemistry, or time patterns that suggest an engine's exhaust rather than sunlight's patient hand. It would mean a line that brightens and fades on a schedule tied to maneuvers, or a frequency that steps in a way nature doesn't, or an emission that sits where no catalogue expects it. Heat is another kind of light. Mid-infrared instruments watch for warmth that lingers where sunlight alone would not, or that appears as beads along a structure, rather than the smooth gradients a dusty coma prefers. A comet warms, vents, and cools with the sun. A powered system must dump waste heat, and radiators glow in patterns. If several telescopes at different dates and angles saw the same hot point sliding with the nucleus, yet not obeying solar geometry, we would take notice. Brightness has its rhythms too. Many comets tumble, and their light curves rise and fall as sunlit faces turn. If that spin damps suddenly, or if sharp, mirror-like flashes repeat with machine regularity, instead of the soft, imperfect cadence of a rough surface, the lamp on our table grows brighter. Specular glints that keep the same interval over weeks suggest flat panels under control, not ice and dust turning by chance. A tidy period can happen in nature. Sustained regularity under changing torques is a different story. Imaging is the most tempting lamp and the easiest to fool. A single sharpened frame can hint at ribs and rails where there are only gradients. So we ask for the unglamorous things: raw files with headers, field stars for scale, the exact filter used, the sequence that shows whether features rotate with the body. We ask for repetition: one camera, then another, then a third, at a new angle with a new star field behind it. The same structure should survive new optics. It should persist when filters change. It should remain when the seeing is poor and when it is crystalline. Photons from the sky are patient. Artifacts from software are not. To keep our lamp honest, we also list what won't help much. Ground radar will not paint a detailed picture at these distances, so a lack of radar echoes tells us nothing. Crowded, over-processed clips tell us less than a single raw panel with coordinates. Hints that appear only during solar conjunction and nowhere else will always rank below features that return after the glare lifts and the geometry is kind again. Communication deserves a separate note. If an artificial visitor transmits, radio telescopes could catch a narrowband carrier, one thin tone among the hiss that drifts with Doppler in a precise way and perhaps carry structure in time. Such a detection would not live on social media first. It would arrive with timestamps, telescope names, integration links, and a recording that others can play through their own software to verify the signature. Transparency is part of the evidence, not decoration around it. All of this folds into one gentle standard. The extraordinary claim needs many small lamps lit at once, astrometry that insists on a push, spectra with lines that don't belong, thermal maps with bright points that behave like hardware, light curves that keep time too well for too long, images that agree across instruments and angles. The same story told by different eyes, each with its own calibration, its own noise, its own ways to be fooled, and all of them refusing to be fooled in the same direction. It is tempting to set thresholds like fence posts, this many arcseconds of residual, that many degrees of thermal phase lag. But the truer boundary is consistency across methods. A modest DV that aligns with a thermal anomaly and arrives alongside a spectral change says more than a dramatic image by itself. The inverse is also calming. 3 clean nights that match gravity plus a reasonable outgassing model, with spectra and heat behaving as expected, will lower the flame of doubt more effectively than any denial, because nature's quiet is cumulative, and over a week of honest measurements, the sky writes comet in letters, so even you can read them without squinting. What we will not do is confuse feeling with finding. A clip that looks right does not set our lamp on fire, and a week where Earth's view is bad does not count as evidence of secrecy. We have the tools to measure motion, colour, and heat, and we have the habit of sharing raw data so others can check our work. If a case is to be made, it will be made in those shared files and in the residuals printed from them, not in the friction heat of excitement. And in the second half of the night, when the numbers are posted, the headers intact, the star field matched, the timestamps aligned, the most surprising part is often how gently a truth reveals itself, because once you've lit enough small lamps, the room is bright, and no single candle needs to be a torch. So we keep the lamp on the table, and we keep the list short and honest. Motion, spectrum, heat, rhythm, shape, provenance, replication. If several of these burn at once in ways comets don't, then we will say so, plainly and without rush, and if they do not, we will let the traveller be what it has always been in the numbers, a small, warming body moving on a clean curve past our star, and we will sleep well, because the path we took to that answer was careful. Here's the calm, tucked inside the numbers. Night shift in the lab, lights low and kind. Flat fields hum through the pipeline, dark frames whisper their quiet pattern, and bias images lay down the baseline texture of the detector. On the bench sits a mug no one drinks, catching the glow from a status LED. We aren't chasing secrets. We're repairing a fabric, thin places, loose stitches, and seams that need pressing, so the picture doesn't pucker when we pull it taut. Calibration is the loom. Every exposure has threads you don't want in the final cloth. Thermal signal, read noise, the gentle snow of hot pixels. We weave them out by measuring them first. Darks record the camera's warmth so we can subtract it. Bias frames tell us the detector's 0 point. Flats capture dust motes and vignetting so the pattern won't warp at the edges. None of this is glamorous, all of it necessary. A single missing flat can make a halo seem like a ring, a dust speck like a dot of intent. So the night shift takes its time, Provenance is another stitch. Astronomical images are born with headers that list the instrument, the time, the pointing, the filter, the exposure, even the detector temperature. Those headers let anyone else unroll the same bolt of sky and check whether the weave matches. If the data arrive without the labels, if a clip is stripped to a bare, compressed panel, then the fabric loses its selvage. Pull on any one thread and the edge frays. That's why real releases include the raw files, not just a sharpened crop. Now to the quiet reasons a picture might not arrive when the timeline in our heads wants it. Calibration takes hours. To days when the detector is quirky or the sky uneven. Pipelines catch up after power outages and weather breaks. Staff schedule time to stitch the frames together and double-check the seams. Spacecraft add their own constraints. Sun avoidance angles keep hardware safe, so there are parts of the sky they will not touch. Some instruments retreat when the thermal load rises. Others pause when the geometry turns risky. None of this is shadowy. It's a care label sewn into the back of the image. Proprietary periods are the label's fine print. Many ground facilities grant the proposers a window, often 6 to 12 months, to analyze the data they worked to win. Hubble classically kept a year for most programs. Large European observatories often do the same. Survey projects blend immediate previews with slower, curated releases. Other platforms, like JWST since Cycle 1, moved to zero proprietary for many observations, so the cloth goes on the public bolt almost as soon as it comes off the loom. The variety isn't secrecy, it's policy, designed to balance fairness to teams with value to the community. Solar monitors and planetary missions have their own cadence. Soho and Stereo publish quick-look coronagraph products fast, then follow with reprocessed versions once the scattered light modeling is tuned. Mars orbiters submit packets to ground stations and wait their turn in deep space queues. If a conjunction puts Earth, Sun, and spacecraft in a line, radio noise and charged particles can ruffle the transmission enough that teams hold the data until the channel is clean again. Think of it as letting the fabric rest before you cut. Boring reasons multiply usefully. A schedule change for a guidance star because it wandered behind the dome slit at the wrong hour. A failed twilight flat that left a gradient across the field. A saturated exposure that bloomed more than expected and needs masking. A pointing that drifted by a few arc seconds because a wind gust nudged the mount. The log fills with small, patient notes, none of them dramatic, all of them resolvable with another night, another attempt, another pass through the pipeline. And there are the safety seams. Hubble avoids the sun by about 50 degrees. The moon and Earth have exclusion zones as well, because bright edges and scattered light can scorch the sensor's delicate cloth. JWST keeps its boresight between roughly 85 and 135 degrees from the sun to protect the cold optics behind the sun shield. Ground telescopes draw their own bright object limits, so the fabric doesn't glaze in the light. If a target slips into those keep-out cones, the loom goes quiet and waits. A long, even sentence for the second half of the night. Because the sky is stitched from geometry, policy, and hardware limits, and because the images we love are the end of a process that must subtract noise, correct field unevenness, conform to safety angles, respect proposer rights, and pass through checkpoints where people with practiced hands run fingers along every seam. A lull between a remarkable night on the sky and the public appearance of that night's photons is not a sign of hidden patterns, but a sign that the fabric is being finished correctly, so it won't unravel the first time someone else tries to pull meaning from it. What, then, of silence? Most of it is simply the hum of the loom working. Sometimes it is a short proprietary period doing its normal job. Sometimes it is an operations team minding the health of a spacecraft when the sun climbs too close. Sometimes it is the check that the headers are right and the flats good before a file leaves the archive. In the rare case of an anomaly, committees meet, instruments are tested against calibration lamps, and the cloth is inspected under brighter light. Even then, the outcome tends to be a technical memo and a fix, not a secret drawer. When the data do appear, they arrive as bolts, not as scraps. Raw frames with the labels still attached, processed versions with masks you can inspect, summaries that explain the pipeline steps, and ephemerides that let you tie each stitch to a place on the sky. If a claim depends on a panel that cannot be retraced to those bolts, the gentlest thing we can do is set it aside until the cloth shows its edge. And if a week passes, or 2 or 3, we remember that the goal is not to be first to the cutting table, but to be sure the pattern we trace will still fit when someone else lays it down. In this lab, on this shift, that's the whole work. Mind the loom, mind the labels, mind the safety seams. Let the fabric rest when it must. Release it when it's strong. The story is calmer when told that way, and the sleep is better, because the truth you carry into the dark is stitched to things that hold. We return to the quiet traveler. Listen with me for a moment before we look. A dome fan lays a low note under the night, a guidance camera clicks its tiny relay, a clock counts in clean seconds that never hurry. That soundscape is the mood for what comes next, because what to watch is less a headline and more a rhythm you learn and keep. First, the beat that returns as soon as Earth slips past the sun's glare. Positions on the sky. Astrometry begins again in early November, and the sequence matters more than any single frame. Observatories, large and small, will record right ascension and declination against trusted star catalogues. The Minor Planet Center will ingest those points. Orbit fitters will compare the fresh track to the curve predicted weeks ago. If differences wobble around 0, the old model holds. If the points lean consistently in one direction, the new model will absorb that lean, and we will have measured a push or confirmed the absence of one without hubbub. The ear you bring is the ear you use for a metronome, steady, patient, counting measures, not flourishes. Next, a gentle harmony from the spectrographs. Expect the familiar lines to keep singing. Cyanide in the blue, hydroxyl tracing water under ultraviolet lamps, carbon dioxide in the infrared, while the balance shifts with distance and heating. If the earlier CO2 forward signature yields to stronger water products after perihelion, the chorus fits a comet warming and cooling as it should. If nickel lines persist alongside a late iron entrance, that, too, lives in chemistry we already understand. The test is not novelty for its own sake. It is coherence across time, colour, and instrument, the way a theme repeats in a symphony while the orchestra modulates around it. Photometry adds its soft percussion. Light curves reveal rotation when the coma is calm enough. Even with a bright halo, careful differential measurements can find a period. If the nucleus tumbles, the brightness will sway. If activity quiets, the sway may sharpen into a clearer tempo. And if specular flashes, mirror-like little pings repeat with machine neatness. They will do so across many nights, many telescopes, and many geometries. In that unlikely case, you don't need a fight online, only a few clean plots with times and magnitudes that anyone can replay for themselves. Infrared work gives us the baseline hum of warmth. Ground telescopes at longer wavelengths and space instruments that can see past the atmosphere will listen for thermal emission that hangs where sunlight alone cannot explain it. A dusty coma prefers smooth gradients from sunward to anti-sunward. Hardware would waste heat in beads or bars. Most nights you'll hear the smooth version. If a quieter structured pattern appears, it will need to appear again and again to count as music rather than microphone noise. From heliophysics watchers, expect a fanfare-free release of coronagraph data spanning the conjunction interval. SOHO, stereo, and sometimes GOES. Coronagraphs push quick-look images first, then refined sets after scattered light is tamed. Those sequences are wide-field and not designed for delicate comet anatomy, but they sketch activity trends during the week when ground observers step back. In the score of this object, they fill a bar the rest of us couldn't play. When the main ensemble returns, the handoff should feel seamless. One more instrument enters after the curtain lifts: the community itself. Pro-Am collaborations will reprocess amateur frames, register fields to standard orientations, and line up light curves from backyards with spectra from mountainsides. This is not a noisy choir, it's chamber music, small groups matching pitch and tempo by ear, and the resulting score is often steadier than any solo performance. When you see a plane panel labelled with time, coordinates, filter, and exposure, that's a note you can trust. When you see the same panel next to a star field match, that's two notes in harmony. When a week of such pairs traces the same melody, you have a phrase you can hum. Let's set down a short listening guide you can keep near your pillow. First, note when astrometry restarts and look for words like residuals and RMS in the summaries. Those are the deviations that tell us whether a push occurred. Second, scan for spectral keywords OSH, CN, CO2, NE, NI, Fe, and watch how their strengths shift with dates. Gradual sensible changes are a lullaby. Sudden, unphysical jumps a snare drum. Third, glance at light curve plots for steady periods or the lack thereof. Either can be ordinary, but abrupt damping invites a second listen. Fourth, give infrared notes their due. A bland, dust-driven thermal profile is a lull. A bead and bar pattern that repeats is a bell. Through it all, remember the oldest motif. Distances remain large, trajectories remain safe, and none of this music points toward Earth in any alarming way. Now, an ambience weave to let the shoulders down. No new facts, only sound. The dome breathes in a soft mechanical sigh as the slit shutters tap and stop. Grass stills under a shallow wind, and a fox somewhere makes a question mark sound before deciding the night is enough as it is. In the control room, a kettle clicks off and no one paws. The warmth alone is company. A red headlamp finds a notebook margin where a pencil waits. The pencil makes the faint grit song of graphite on paper, steady and human. Out under the sky, the quiet between crickets grows as temperatures fall, and the uncountable hush above returns to its usual enormous silence, which is not empty at all, but saturated with a kind of deep, patient listening that doesn't ask for your attention so much as it holds it gently. What you will not need to listen for is drama. if the outbound path matches the expected curve within the ordinary wiggle of outgassing, that will be the softest, truest cadence we could hope for, and it will arrive in plots you can read without squinting. If the path refuses to fit without an extra push, the change will stand up on its own and will be heard in the same places. Residuals, spectra, heat, rhythm, without anyone having to raise a voice, because the sky does not argue, it only keeps time until we hear the beat. And in the long sentence I promised, meant to float you toward, rest. The next few weeks are not a cliff edge, but a measured coda in which familiar instruments resume their parts. The lines you already know, safe distances, hyperbolic geometry, a CO2-led coma with a sunlit jet. Either continue in tune or modulate in ways we can play back and check. So the kindest thing you can do as a listener and as a sleeper is to let the room be quiet, let the clocks count, and trust that this music, like most sky music, will end without surprise. Here's the calm tucked inside the numbers. You've reached the quiet edge of the story we can tell tonight. A visitor discovered on July 1st, 2025 by the Atlas survey has flowed sunward on a hyperbolic path, warm enough near October 29-30 to shed a small, bright coma and a sunlit jet. Distances stayed broad and kind, about 1.4 astronomical units from the Sun at closest pass, near 1.8 astronomical units from Earth later on, so safety never left the room. Instruments old and new offered their parts. JWST showed a CO2-forward chemistry. Ultraviolet cameras traced water through hydroxyl. Large spectrographs noted cyanide and faint nickel. Coronagraphs bridged the glare weak. Mars side orbiters watched from a different angle when we could not. From here, the rhythm is simple. Ground telescopes recover the target in early November. Positions get compared to predictions. Spectra remeasure familiar lines. Photometry listens for rotation. Infrared checks for warmth without drama. If the path matches the old curve within the small, lumpy pushes of outgassing, the story remains a comet, passing by from another star. If a change insists on itself across nights and methods, we'll hear it in the same steady places. Residuals, lines, heat, rhythm, without any need for noise. Thank you for sharing this gentle watch. You chose calm instead of hurry, numbers instead of rumors, and that choice is a soft gift you can carry into sleep. Let the low fan hum, let the clocks tick, and let the sky keep time for us a little longer. Wherever you are, may the night air be easy and the room just dim enough, and may you drift off with the simple assurance that the universe is vast, orderly, and patient, and that the instruments will be waiting when you wake. Good night.